Hi, I am Arturo Tik. This is the presentation of ELE 411 term project. Huffman coding is a lossless data compressing algorithm. The idea here is assigning lower length codes to most frequently used characters and don't assigning codes to unused characters. Huffman coding project has two programs. One is Compressor and the other one is Decompressor. Compressing process has 5 steps. One is the reading message from file, constructing tree, serializing tree, encoding message, and writing to output file. Decompressing process has 4 steps: reading input file and constructing tree, decoding message, and writing message to output file. Input can be read from any file with ASCII characters in it, message saved into a string, and null character appended to report end of string to the receiver side. Program creates a new node with character and number of occurrences for each unique character in the message. The function getFrequency takes input string, an array of node objects, and appends the character of message with their number of occurrences into array. When all the leaves are created, program sorts them according to their number of occurrences. Program uses quicksort algorithm to sort them. Then program starts to construct a tree, search 2 neighboring nodes with lowest sum, then connects 2 of them with a parent node with value of sum, then repeat it until reaching the root node. This is the root node. Constructor function of tree class creates a stack and pushes all leaf elements into the stack, then calls a function called construct tree. Construct tree is a recursive function. It creates an auxiliary stack and picks first 3 elements of main stack. It compares previous item with next item until it finds the 2 neighboring leaves with lowest sum. Then it creates a parent node and links the 2 neighboring nodes. It pushes the parent node and the remaining ones in the auxiliary stack back to the main stack. Then calls itself until it remains with root node. Next step is serializing tree. Program saves the tree into output file for receiver side to decode the message. This part is handled by a recursive function. The function puts a 0 bit for each left from parent node until it reaches a leaf node. It writes 1 to report it reached to leaf and puts ASCII character of leaf node. Then calls the function for the right side of the parent node. By the time, while the function traverses around the tree, it also creates a lookup table to encode the message easily. We must follow different paths for each unique character on the tree. This path represents the code word of the character. Each left represents a 0 and each right represents a 1. Program encodes the message using the lookup table created before. The compressed message is written in an output file with a CMP extension. C++ is not allowing to write the data to file bit by bit, so program uses a buffer to collect 8 bits, then writes 1 byte at a time. First step of decompressing is reading file. In this time, we need a buffer to read individual bits in our file. Buffer reads 1 byte and gives us bit by bit. This is the definition of buffer class. ReadNext function reads the next byte of the file. Get command gives single bit from buffer. GetChar gives 1 byte from buffer. Decode char and decode message functions are for decoding the message. Again, constructing tree from serialized data is handled by a recursive function. Function reads 0 for each go left command until seeing a 1. 1 means leaf is reached. Program saves its ASCII character and recalls the function for right of its parent node. Third step is decoding the message. Program reads single bit as a command at a time and do what it says. 0 means go left and 1 means go right. After reaching a leaf node, we can write its character, then continue with the next code. For example, we have this code here. It says 0, 0, 0, 0, 0. We reach the leaf, which is I, put it into our message, then read the next, which is 1. It brings us the space character. And then after whole message solved like this, we left with our original message. Decode message function implements the previous algorithm. Program saves the original message into a file. This is our file, and this is our message. Longer it takes, better it compresses. As you can see, the program created the compressed file. You can see the original file and the size of it, and the compressed file and the size of it. And I'm deleting the original message. And it decompressed the message and saved it into the file. As you can see, the same with the original one.